AC circuits. Understand my point?
Yes, sir.
To study AC circuits, we should know about the sinusoids and phasors. Phasors is actually in complex number. If you remember, you studied something like iota in FEC 12th class. Remember?
Yes.
So that kind of portion is phasors. And sinusoid is sinusoidal voltage and currents. So, for example, V is equal to V max sine omega t. So this I got this sine wave. Okay. Picture? So now this is in sine wave, and this is the kind of standard representation for any sine wave. In this sine wave over here, we got in peak value or maximum value of the wave or voltage and current. So here it is in peak value. This is positive peak, and here it is in negative peak. Understand? So it is in V max, maximum value or peak value. So here it is in minus V max, negative maximum value of the voltage and current. Here it is in current. Sorry, time. Now, if we got in alternating wave, we will have an time period for this wave, we will have in frequency of this wave, and we will have an that is in periodic and non-periodic. These are the characteristics of waves. For example, I got two waves over here. One is something like that. And another one is also in sine wave, but something like that. Here is, both are in AC waves, alternating. These are alternating waves, time. With respect to time, it changes value, alternating. For example, here it is in voltage value. But look at over here. There is some, a difference between these two waves. One wave is periodically change. Another one is non-periodic. So this wave is periodic, change its value and position with equal interval of time, or repeat itself with some sort of time, or after some sort of time it's repeat itself. For example, how you will find that this wave is periodic or non-periodic? You will take one point on that wave and go further. Whenever you found and that point again, and then again, this wave is in periodic wave. For example, and that will be the time period. Look at over here. When the wave form is periodic wave, there will be in time period. There will be in time period. And for the non-periodic wave, the whole wave is the time period of that wave. You will take, when you will found an average value of that wave, you will consider all of the given wave values. And if you got in periodic, you will just take in a time period. For example, look at over here. I just take this point. For example, 0 or something like that. For example, 0. Or maybe this point. Just above the 0. And I'm just going further, over here. Just go further and further. And whenever I got this point again, that will be the time period of this wave. So look at over here. Over here I just found the same point. Same value and same point. Understand my point? And when you go further, over here from this point again, you will find again over there, So, what will be the time period for this wave? You just take this point, and whenever you form that again, that will be the time period for this wave. Understand my point? Understand my point? Now, for example, you took in this point and just go further, go this. So now time period, and both of the time periods same. Understand? If you take this 0 value, but look at over here. It is a very important point should be discussed over here. I just took this 0 value. On a first glance, you will say that I got 0 again over here. Is this a time period for this wave? Something puzzle, mixing up. If you say that I just take this 0, then what will be the time period? I got this 0 over here. Is this a time period or this is a time period? This is very small, So what is the point? Point is, I just take this 0 position, but this is upgoing 0, After 0 it is upgoing. But over here, I got 0, but this is downgoing. So this is not my point. My point will become over here, this 0, which is upgoing. Understand my point? Yes. So that will be from this point to this point, that will be your time period, over here and over here, that will be your time. So again, this time period is equal to this time period for this. Understand my point? And we can represent this sine wave with this one. V maximum sine omega t. T is the time. This time. For example, V is equal to V max sine omega t. What is this omega? Omega is equal to 2 pi f. Omega is 2 pi f. F is frequency. Understand my point? And time period t, time period, 1 hour frequency, or vice versa. F frequency is equal to 1 hour time period. The unit of this is hertz, and this is maybe second or millisecond. Seconds. Okay. Yes. Understand my point? For example, I got this. V is equal to 120 sine 300 t volt. And I just asked that found maximum value of voltage for this value, for this given data, for this equation, and time period and frequency Understand my point? And for example, value of voltage, instantaneous value of voltage at, for example, 3 milliseconds. Understand? So, can you find a maximum value for this? Is this a maximum value or not? 120 V max. Instead of V max, I got 120. So the value for maximum voltage is 120 volt. Understand? Time period. How can I find time period? Look at our hair. How much omega is in this equation? 300. This one. So omega is equal to 300. Understand? What is omega? 2 pi f is equal to 300. F is frequency, and 300 divided by 2 pi will divide over here. How much is this one? Did you got a calculator? 47.74 hertz. Understand? So whenever you got in frequency, you can calculate the time period of this wave, which is time period. Time period is equal to 1 over f, and how much is 1 over 47.74? How much is this one? 0.020. And in millisecond?
9467.
The 1, 2, 3 kana. So here it is in 20 milliseconds. This time period. So what will be the value? What will be the value after 3 milliseconds? That is an instantaneous value of that sine wave. Understand my point? Yes. The point is kana. So what is an instantaneous value? Instantaneous value is the value of voltage at any instant of the wave. Because it is changing its value with respect to time. Voltage value is changing, with respect to time. So at any instant, when you calculate the value of that voltage, that is called an instantaneous value. For example, I am calculating the value of this instant. For example, I am calculating the value of voltage at this instant. For example, I am calculating the value of this instant. So this point or this value of voltage will be an instantaneous value of this voltage. So for example, I am calculating in 3 milliseconds value of the voltage after 3 milliseconds of the time period, because I got a 20 millisecond time period. So here it is, for example over here. Time period. How much is time period? 20 milliseconds. So what will be the value for 3 milliseconds? What does it mean for 20 millisecond time period? What does it mean? It means that half of the time period is 10 milliseconds. From this to this. Kana?
Yes, sir.
Again, half is 5 milliseconds. Which way?
Yes, sir.
And 3 is above the half of the 5, and we got a peak value of how much? 120. So that will be something like bit more than 60 volts. Bit more than 60 volts. So how you will calculate that? It should become a bit more than 60 volts. So that will be V at 3 milliseconds, so 120 sine of 300 into 3 10 to the power minus 3. Understand? So 120 sine of, how much is this one? 300 into
0. Minus 0.8.
0.9.
0.9. Ada kata sulit.
1.8848.
Oh. 1.8848.
8848.
Da video fun na kai. डिग्री की दे का रेडियन के व्यवस्था कैलकुलेटर
सर डिग्री की
और दा रेडियन के तो रेडियन के वाच होगा did you got the point? Because this value is in radian omega
जी
omega radian के देखा ना
Yes, sir.
दा बता रेडियन के आले
जी
और Shikala, the degree TV no. So this is the point you should care of your calculation. When this value is in radian, you should see that your calculation is in radian in your calculator. And if it is in degree, then you should change the mode of your calculator to degree. And how about the degree and radian? Because this omega is in radian, we didn't convert this radian value into degree. So that's why we will change our calculator mode to radian. That after that we will have how much a value for
93.99.
93.99 volt. So, is it more than 60 volt?
Yes, sir.
Yes, sir. Kana? Happy now?
Yes, sir.
Are you happy with this?
Yes, sir.
Did you like this?
Yes.